Hi everyone. Welcome to a quick stream. There's my phone notifying me that the stream is starting. Wonderful. All right, so today I won't be making this a super long stream. I just wanted to get into kind of an interesting demo of something else that is, yes, related to this old circuit simulation adventure game, Robot Odyssey. And this was just something else I was playing with recently that I thought would be interesting to show off a little bit and play around with on stream for a little while. So, hello, I'm Micah as usual, and I think Tuco is sleeping upstairs, but I'll see if I can get the camera on him when he's around. I know the camera's ceiling vision. Alright, so we've done some streams recently about this game, Robot Odyssey, which has been a bit of a diversion from my usual electronic stuff. And I figure I'll just kind of, well, see where the next step in this obsession leads. And I really wanted to see what would happen if I could connect something in-game to something out-of-game. You know, I've wanted to, you know, try making like an Arduino room or something like that, where in the game there would be some representation of a physical Arduino or physical robot, and you could go inside that and wire it. You know, I don't know how practical this is. Like, from a more practical standpoint, this has been teaching me some technologies like WebAssembly that might be useful. As far as the connection between the game and the outside of game, that's been mostly just leaving me kind of frustrated at the current state of web APIs. Because, for example, if I go to can I use it? Is that just caniuse.com? I always forget whether it's can I use it or can I use, but it's can I use. If you search for USB, there is this somewhat horrifying but also somewhat useful thing called Web USB, where if the device opts into it, you can actually basically get like libUSB style user space USB communication from a web app. So with WebUSB and Chrome, you can connect a sort of properly configured Arduino running firmware that's compatible with WebUSB. You can connect that directly to your web app and control the Arduino's IOs or send data to some custom sketch you have running on the Arduino. So that could be a route forward, but I don't want to rely on APIs that are Chrome only if possible. The other option might be, there's Bluetooth, but same story, Chrome only. And this one is even scarier to me because, like in the current implementation, I think it's pretty much just like opt-in connections to Bluetooth low energy devices. But looking at the proposed spec, there's like stuff that isn't necessarily implemented that would let web apps actually scan for nearby Bluetooth devices. And that, I just have a hard time imagining that being a good idea, but I don't know, man. Chrome is like some kind of operating system now. So yeah, USB, Bluetooth. There's also Web MIDI, which would actually be interesting for various reasons. I was looking into this some more. There is actually a polyfill that works on non-Chrome browsers. It actually uses a plugin. I think there actually is one that uses like a Netscape-style plugin, and one that uses, what is it? I think a Java applet? I don't know, but it's like polyfill, so they would be using that little bit of undesirable technology to actually bridge the MIDI connection back to JavaScript. So I don't know. I've used Web MIDI in the past for like making sketches of apps that used MIDI controllers as inputs, and that was pretty nice. This one seems to be a little bit less likely to be Chrome only forever, but still, for the most part, is basically Chrome only. Anyway, so, and then on the other side, as far as interfacing this to the game itself, I mean, I should also add that, like, I'm just looking at browser APIs here. Obviously, you could write some separate app that connects to the real world, exposes a WebSocket or other interface. You could even just have HTTP REST interface. It's pretty easy to glue things to browser apps via the network, but I was just looking into what you could do just from inside the browser. I should also mention this framework called Johnny 5 in JavaScript, or not FS, I meant JS. I think Google knew what I meant, but pardon my throat. I've still got a throat full of gunk lately. Let's see if the tea helps. So yeah, this is interesting. This is a platform that's intended to make it easier for people to program like Internet of Things style devices, basically microcontrollers, with JavaScript. It even includes this llama with a sad plant, and instead of just watering the plant, they decide to learn some JavaScript. And a fancy Arduino with an LED. All these frameworks have like really nicely drawn Arduinos with one LED attached. But yeah, one thing that's nice about this is it basically has this pluggable I/O layer so that you can run it either natively on a board like a Raspberry Pi, or over Wi-Fi, or Bluetooth, or Serial. But it seems like it's mostly intended for Node.js. So I've seen some attempts at running this in the browser via Browserify. I think just in general, though, it tends to be using like I/O modules that are written for Node. So I've seen, for example, someone wrote like a web Bluetooth-backed implementation, like a polyfill that looks like the Node serial port library. So you could use something like that. We might do something like that in a future stream. It seems a little bit less awful to use maybe a library like this to talk to some like remote control GPIO firmware, but over Wi-Fi, so that you can use like WebSockets or Rust. Rest, not Rust. Rust would be nice too, but right now, just thinking about how to get out of the browser. So, and then on the game side, so the game, you know, if you've seen any of the past few streams, it looks like this, basically. 1984 CGA graphics, but based on circuit simulation. And so there's sort of a sandbox in the game where you can build circuits and burn chips, and it's also been kind of an interesting area to just tinker around with the internals of the game. Excuse me. So then, if you look at the source code for this project, I've actually got some notes on the in-memory format that the game uses for the world and the circuits, which I did some more documentation on that this morning, and the circuit data format is pretty complete now. So yeah, actually, these objects are kind of interesting. They're one of the tightest limitations in the game's engine, now that I'm understanding how this game works internally, is this limit of 256 objects. And not everything is an object. Like a lot of the kind of background stuff on the screen are not objects. Basically, if you can grab it or solder to it, it's probably an object. And so this table has object IDs. Some of them are used differently depending on which of the game's binaries you're in. So for example, the game has this extra robot called the master computer. I also wrote down some of the other objects we came across, like a vending machine handle and a Dalek, and this subway token. And then some things are only in the innovation lab. So, for example, the large prototype chip and the whole chip burning system is only in the innovation lab. And as I'll discover, like these things take a lot of sprite IDs as a resource. So, like having all of this in one binary would have exhausted probably just the memory they had, but also the sprite IDs. And then there are a lot of common things. Some of the objects are kind of repurposable, so like there are general purpose game objects and sensor objects where like the functionality of the direction sensingness or the context sensingness or whatever, that part is coded, like hard-coded in, but the actual image on the sensor is just set using the object system's table of sprite IDs. So the world already has this database of sprites and sprite locations. Excuse me. So object locations, object rooms, colors, sprites, and the electrical subsystem in Robot Odyssey actually uses a lot of these for kind of a dual purpose. So any object that's electrically relevant, the color also indicates whether it's electrically hot or cold. So if it's the kind of electrical color, like that electrical orange color, that's like color 5, and that means that it's a logic 1. If it's the plain white color, then that's like color 7, I think, or logic 0. So the colors are actually used meaningfully to store state in the electrical, like the circuit system. Some of the sprite IDs are meaningful too. So there are 256 objects, and those are just different instances of an object. But then sprites are something with a unique image. And I haven't annotated this in the data file yet, but actually there are special sprites. So like there are, from just experimenting with the game, I've noticed that there must be a range of sprites that indicate like electrical inlets and outlets. And there's some code in the soldering subsystem that understands like exactly where the solderable point is in each of those sprites. And there's some code that understands like which of these sprites represent inputs or outputs, or which of them are just not electrical. So I assume there's probably just like data tables in the game's binary elsewhere that we haven't looked at that have data like that encoded. So the world, locations. It also has this system for objects that can sort of hold on to other objects. So you can use this for like picking up and putting down objects, like pickup mechanics. But you can also use it to make multi-part objects. So these sprites are pretty limited. They're, I think, 7 by 16 pixels each. But the larger objects in the game, like the robots and the Dalek and the big chip, those are made by linking together many sprites. Even the gates, every logic gate in the game is actually 3 sprites, one for each input and one for the gate body/output. And sprites are also single colors, so anytime you see an object with multiple colors, that's actually a collection of objects that are all interlinked. So there's that. There's room data, which is like a low-resolution bitmap, a linked list, or links for up, down, left, right, foreground, background, lists of objects in each room. And then, yeah, most of the code I've been writing hasn't been using the object linked list. I've just been brute force scanning this array, but the way the game keeps track of objects is actually by having a linked list that keeps track of which objects are in each room. And I should really write some JavaScript code to update that. So then there's this section I'm calling text. I think some of this is text and some of this is actually like other like random like special objects, but I think most of it's text. I think this style is actually like an object type, and so it's like room XY, the type of object. Font is pretty much what it says on the label though. And then this is a 16-bit pointer split up into 2 halves into this longer string heap. I think some of this memory might be used for other stuff like chip descriptions, but that's like a Robot Odyssey-ism. This overall data structure is kind of a holdover for the older game engine that Robot Odyssey is based on, and I think that game engine, as far as it's concerned, this is all string heap. I think Robot Odyssey just uses some of it for chip data. So then circuit. This is like the stuff I reverse engineered this morning, basically. Like we started this on yesterday's stream, but it was all pretty hand-wavy, and I didn't really have that much concentration left in me, so I kind of worked through the rest of this morning, basically just subdividing the address space into like chunks of unknown data, and then based on just like testing, like building circuits in the chip and like lighting them up with the hot cursor and diffing this data, figured out what they did. And I can get a much better intuition for how the simulation engine works now. It's very output-centric. Like everything that generates an electrical signal has various resources associated with it. So everything that is an object has the ability to generate an output. So I was noticing, like, at first I was just labeling this a table of wires, and I was noticing, oh, wire 0 seems to be the hot cursor. But no, actually it's that the object 0 is the cursor, and when you turn it into the hot cursor to like test your circuits, it's actually creating like an electrical output driven by the cursor and using its object slot for that. So then, yeah, it has 2 endpoints, another object ID for like where this drives, so the electrical engine kind of propagates signals from place to place. There's separate storage for flip-flop inputs and outputs. I'm not entirely sure why they needed separate storage for this, but it might have been convenient. Like, it seems like this is redundant with the colors of the flip-flop sprites, but this is specifically the current state of the flip-flop, whereas this is specifically the inputs being applied to the flip-flop, which can be different. And I think there are some cases where that's necessary to render wires properly. I don't know, though. It would be interesting to look into the code that uses that. The game has nodes that split the electrical flow, so let's look at the toolbox. So it's also become clear that the reason these limits are so low is that all of the sprites that these objects are all made out of have to fit in that 8-bit address space of 256 sprites. So every time I take out a node, so like the gate, for example, this gate object has an output which is now associated with this wire, and I can connect it to something else. And now this wire is driving this sprite. We came up with a neat little overlay script on the last stream, which I think I'm going to use to illustrate some of what's going on here. I have this messy file of notes with some like script one-liners that I've been keeping. Yeah, visual debugging. So I was using this diff script a lot, which just watches memory and prints out differences. Visual debugging. So if I pop open a console here, looking at what this script does, I mean, we wrote this on the last stream. Let's see. So I'm saving the old onRender frame, which is kind of an internal callback used by the emulation to, it's a call made from the C++ side back to the JavaScript side every time a frame is happening, or every time a frame is being dequeued from the output queue. So it's really, really not per game tick, and it's kind of not per game frame even, because it's like on the DQ side rather than the NQ side. It's kind of a hack. It's like the closest available place I had to hook in code. The proper way to do this will be to probably add some hooks in the game that are per game tick and per circuit simulation tick specifically, and then just like add an easy way to just drop in additional JavaScript callbacks. So that kind of thing would be nice. For now, I'm just doing this the hacky way, and I have this separate function render that takes a canvas context just to make it easy to edit this without having to constantly juggle render frame function pointers. And then on render, this just sets up the canvas. It's looking for objects that are in the current room. So as I was saying, there's a linked list for this, but I'm just brute forcing it and scanning all the objects and comparing whether they're in the room that the player is in. Excuse me. I should also really make some nicer JavaScript APIs for this. I've just been kind of hacking it by just like calculating the hex addresses manually in the world here. All the reverse engineering this is based on is very new, so it's like only just barely getting to the point where making an API for this would be sensible. So then any objects that are in the current room, I'm kind of hastily converting from the game's coordinate system to the canvas's coordinate system. This is not quite right, but it's close. And then drawing some text there with the object ID. Unpop up this, there we go. Okay, I made that a little more translucent than it really needed to be. Let's bump that up to 80% opacity maybe. Alright, so this is the main debugging tool that was helpful on the last stream, which I admit was very tedious. I wouldn't be surprised if any of you managed to catch some part of the last stream tuned out, because it was a lot of just figuring out which objects go where and figuring out how this 256 object space has been allocated. So anyway, we've got a pretty good idea of what these object IDs are actually used for now from doing this. I still don't know what AE is, do I? Train. Oh, really? AE AE is just one of the gates. If I pop up my toolbox and start using gates, will I eventually displace that AD? Let's do a little experiment. That's a gate body, so it doesn't matter whether I'm using a 2-pin or a 3-pin gate. So you can see these numbers are increasing. The gate body went from 7.0, 7.5. It's really hard to read. Oh, that was it. So I guess that was just a leftover part from a gate. That's weird. You know, I wonder if that was a slight corruption in the file. You know, maybe that was a sprite that had its room ID set to this room, but maybe, like, I suspect if I looked at the room's linked list, it would not actually appear there. So that's interesting. We might have just found some memory detritus. Like something that used to be in this room but wasn't, or something. Like I don't know. Like the game's data files largely just seem like memory dumps from editing tools that, you know, they would never have any reason to clean up stuff that was left over from the editing process. So this is a bit hard to read, but it was useful. I did a new version of this morning. I was experimenting with doing something with the DOM. So in this version, the coordinate system transformation is going to be a little off here, so I'm not going to be surprised if this just doesn't actually render in the right place, but let's try this. Let's first just like get a fresh page here. So I reloaded the page, which reloads the whole JavaScript everything, but the Robot Odyssey game was saved, so all these little gates and things are saved, for whatever that's worth. Oh, that kind of works. Let's increase the speed too. So this is still kind of hard to read, but I've also got more information here. So here you see that first number is the object ID in hex. I think this is all in hex. The colors are pretty low, so it doesn't matter so far. But so I've got the object ID, the sprite ID, which is the visual appearance that goes from 0 to 64, well, 64 decimal, so 3F hex. So by hovering over these, I can actually change the that output from 5 to 7, etc. So this is maybe a little more useful. It's still pretty messy, but this is maybe a bit more of a platform for adding additional information in the future. Like I was imagining adding like a logic analyzer where each node would have a little trace of past states that it was in, like a little sparkline graph. So just to show how this works, I'm pre-creating 256 divs to correspond with the objects. And every time through, I'm again hooking the onRenderFrame function in this extremely hacky way and calling updateObj on all 256 objects. So very hacky. This frame element is a div that contains the frame buffer, so it's kind of a decent place to parent these divs. And I'm calculating absolute position for them using the client rect of the frame buffer, which isn't quite right. Like I think this breaks if I zoom the page. Yeah. So that could use some fixing, but that was all right for a first test. So yeah, that was helpful. And just using strategies like that and diffing memory. This morning, I think I completed, well, mostly completed the info for RO circuit, which is the other big data structure. So world is like sprite info, sprites, text, rooms. Circuit is about like the state behind the electrical part of Robot Odyssey. And specifically, this does not include the tiny chips. The tiny chips have their own separate system that's more compact than this. But this is what goes on inside the main game world. And so everything is centered on like where the electricity is emanating from. So the hot cursor again is like object 0 in the slot. Gates, this corresponds to the sprite of the gate's output. So there are a lot of unused slots here, right? So like gates are 3 sprites. One of those will be used as an output. The other 2 I don't think show up in this wire table because the wires are all annotated based on where the electricity is originating. So I think the input sides, this would be unused. I don't know. I should verify that. So it isn't particularly memory efficient, but it is straightforward, and it includes like a built-in allocation for all the memory you could need for all the wires to hook up all the objects. So they don't have to worry about running out of space for wires. So every object comes with the ability to have one output wire. Nodes need a second output, because nodes are actually just a single object. Let's open up the toolbox down here. You'll also notice that the contents of the toolbox as it's open, none of these are objects. These are just drawn by separate pieces of code. But as soon as I take it out, now it's an object. I'm curious actually what makes a sprite recyclable into the toolbox. There's, as we'll see in a sec, kind of an allocation system for allocating sprites out of the toolbox. And so I'm curious what modification I would have to make to just any other game object so that you could recycle it into the toolbox and take its sprite ID. And I mean, I don't think allocation works like that. I think allocation, well, I'll show you how allocation works in a sec, or at least what I know about it. But yeah, nodes are a single sprite, single object. And this explains why nodes are oriented vertically like that, is otherwise they would have needed multiple sprites. But this fits entirely in that 7 by 16 pixel cell. And they're always the same color. So, for example, these nodes I don't think have to be the same color. And yeah, in fact, now they aren't because electricity isn't propagating because the remote isn't on. But if I turn the remote on, electricity propagates, and yeah, that's how that works. That's interesting. The propagation from the hot cursor seems to take place whether or not the remote control's on. It just doesn't affect whatever it's connected to next. So yeah, the node has this usual output up at top that works the same as, say, a gate. So gates, 3 objects. One at the top, that's 8B. Then we have 8C and 8D at the bottom. And if I touch this input, it's a little hard to see, but the color is changing from 7 to 5. Same with the other input. If I turn on the remote, so the electricity propagates, the overall gate changes color. So, nodes made of one sprite, and every other gate could be made up of 3 sprites. The NOT gates just don't have a second input, but in every other respect they act like a 3 sprite gate. So they still take up 3 slots in the table. They just have a missing input. Flip-flops are not the same as regular gates, and they're made up of 2 sprites. So interestingly, on the flip-flop, the input side and the output side are not separate objects. So the color of the flip-flop is drawn entirely based on the output state of the flip-flop. So, for example, if let's say I hook this output up there. So the right input actually takes precedence over the left. So if the right input is connected, then I can't override it with the left. And so you can see here that I'm actually lighting up the left input, but it doesn't look like I am because it's just drawing the output state. And if I swap this, oh really? Did I just lie to you? I thought there was a precedence from one side to the other. Is it just stuck now? let's test that again. Oh, I thought flip-flops had a preferential side, but maybe it depends on which one is activated first. That would be me learning something new about how flip-flops work in this game. Cool. Did not realize that. I thought that they were asymmetric, but I guess flip-flops might be symmetric. Anyway, flip-flops are not the same as gates. So we've got wires associated with objects, we've got flip-flop states, we've got wires associated with the second output on the nodes. So yeah, these arrays are all indexed based on each node. So each node has the opportunity to have its second output connected. If not, this is 0. And the wire isn't drawn in that case. And then these, for some reason, have a backwards reference. So this references which object is driving the input of the node. I'm not sure why they needed to include that. But, and then the small chips, the entire small chip is just one sprite, or one object. So they had to have some system for wires that originate from a single pin on this object. So we have 8 of these objects and 8 pins on each one. So that's what this 64 entry set of arrays are for. Wires coming from a small chip. And there's also, because you can connect from one small chip to another, you might need to indicate which pin on the other object you're connecting to. So that's what this array is for. It's usually FF, but if this indicates the entire object for a chip, then you might need to disambiguate. And then there's an allocation table for the gates. These are just 1s or 0s depending on whether the gate is being used. And in fact, this is really inefficient in memory because in flip-flops, it actually only tracks that left sprite. So it's only tracking the kind of main sprite, which is the left side of the flip-flop. Or for gates, it's only tracking the body of the gate, which is only every third sprite. And so 2 out of 3 of those slots are just always 0 in gates, and half of the slots are always 0 in flip-flops. I don't know why they made that decision. It's not that hard to multiply by 3, even in 8086 assembly. But maybe that was a place where they felt like sacrificing some memory for either terseness or performance or something. This one's a little bit of a mystery still, but actually I just recently got some insight into this. I think this is where it stores some state related to swapping between the soldering iron and the normal cursor. Like, I think it actually swaps your sprite ID, and this is like the saved sprite ID for the cursor. In fact, I can just rename this. And I think FD is soldering. Yeah, those are sprites. Yeah, I might rename that because it's not quite the soldering iron. It's like an extra cursor slot that's used for soldering modes. Yeah, that's fine. Okay, so little wires, chips, allocation tables, remote control status, toolbox state, just keeping track of the number of nodes and number of gates and everything. And then you start wondering, well, like, okay, what happens if we start lying to the game in various ways and just making up weird things? So, like, what happens if we start telling it different numbers of gates are in the toolbox than actually exist? Sorry, that was a little off screen. So, for example, flip-flop count 10, that should be at address 790. Oops. It didn't change right away. I set it to 11 just to try my luck. What about 9? Okay, my intuition here is that actually there's some procedure that has to run to convert that number to text. I think that these strings are, like, I've seen these pieces of text in memory, so I think that there are some string templates that it draws these from. So what if I take a flip-flop out? Like, let's set this to a big number, like 20, that it should never be able to be. And if I take a flip-flop out, will I see 19 there? Yes. Now, if I run out of flip-flops, will the game crash trying to allocate a flip-flop that it can't allocate? It just fails to pick one up. That's nice. What if I change the allocation table? So in that flip-flop allocation table at 77A, I should see all the flip-flops taken. Right, that's the pattern in the flip-flop allocation table. So as you can see, we're only using every other byte, but all the flip-flops are taken. So let's deallocate the first flip-flop, and then let's see if it'll let me grab one from the toolbox. Okay, now we just stole a flip-flop from over there. So yeah, so you can start messing with it like that. I was interested in what it was like to modify a gate. So, like, okay, let's get a clear lab here. Sort of clear. All right, so let's get an OR gate. That was an AND gate. Okay, so that's sprites 6, 7, 6, 8, 6, 9. So that should be the first gate. Gate 1, body N1, N2. So there isn't really that much state stored for the gates, other than just like this general purpose sprite information. The way it actually disambiguates what kind of gate it is, whether it's an AND or XOR or NOT gate, is actually by looking at this allocation info. So this gate is OX702. So it is 2, which means it's an OR gate. This is the gate type as far as the circuit simulation is concerned. I could actually set this to NOT, and I guess you couldn't tell because the simulation was off, but if I turn the simulation on, let's get rid of this overlay because I don't think we need it right now. Let's just reload. And since that was a modification to the save file, then it's still in memory. So even though this looks like an OR gate and has 2 inputs, it is now a NOT gate as far as the simulation is concerned. So the second input is actually not doing anything, but I can still electrically activate it. And the first input just swaps the output just like it was a NOT gate. And then, well, what else is really going on here? What quintessentially makes this like a 2-input gate? What makes those inputs? What makes them outputs? And as far as I can tell, everything else is really done with the sprite system. So in RO circuit again, like, well, where else would gate data be? You know, other than the flip-flop state. Other than, there's, you know, I'm not talking about wires. The only gate state here is what kind of gate is it? Everything else is kind of baked into the color and the type of the sprites. So the color is definitely special, but I think actually the image of the sprite is special also. For example, let's try modifying this gate some more. So I don't need the overlay here because I can just look up gate 1 starts at OX67. And I want the sprite IDs, so 167 in world memory. Alright, so that's sprite 9, whatever that means. I can change that to something I know, like sprite 0 is the player. Hello. If that was the game, this would actually be animated, but I could just step through the sprites. I should really just make a tool that just displays all of the sprites. So, you know, this could just be any game sprite. Can I solder to this? It does let me solder to that, but like, where is it letting me solder? It seems like that was the bottom left pin of the chip, right? Like that's... Wait, was that the bottom right pin? Oh gosh, is it letting me solder multiple pins because it's a chip? So I was gonna say, the soldering routines are all special cased based on which particular sprite slot you're soldering from. Oh gosh, so I think the coordinates are messed up somehow here, but I've got multiple pins because it's a chip sprite. That's horrifying. I don't think I'll be able to desolder these wires if I change the sprite, so I'm going to desolder them right now. Maybe I can't desolder them right now. Excuse me. Okay. That works. What about, like, I don't know, something like this? This is definitely not solderable, right? Oh, did that break the entire object? Because usually you can solder to the inputs. Huh. What about this? Oh, maybe I broke the solderability when... Yeah, I think when I was soldering to the chip, I was like corrupting memory somewhere. Let's get a new game here. All right, this is still an OR gate. Let's keep it as an OR gate because that red color was getting hard to read for all the gate bodies. Same memory address. Let's use pre-increment so we can see what it actually is. So anyway, here's like an upside down gate, right? So what happens if I try to solder this? Yeah, it's getting the solder position data from the sprite, so that works. And it knows that that's an output because this turned into an input. What if that was an input? Also knows the position. And it knows that it's an input because of the sprite, and it turned that chip pin into an output. I think, yeah, that wire is being driven by that output, so even though this is being driven as a gate, there's just no, like, that's basically a conflict, and it's not actually propagating out that way. Let's desolder this before I corrupt memory. What about this? Does this count as an output or an input? So I think there might be... Oh, that's interesting. This is an input. And that's the output. So I don't know what the deal is with this. No, that's also an input. Okay, that's the other half of the... Yeah, I don't know how outputs on flip-flops work. Oh, here's an output. This one should work. No? Oh, the hotspot's just a little bit off. It's like a few pixels too far down. Okay. That works otherwise. Interesting, right? So... Whoop. Did I just mess up my ability to desolder that? I don't know. I think we're fine. Oh gosh, what happens if that's a node? Yeah, there must be some weird special case for soldering to the top sides of nodes and flip-flops. Because in whatever default state I'm in right now, it wants to solder to the bottom of the node. Huh. Oh, that's weird too. It swapped that to an output. And now it acted like I disconnected it. So it acted like it was connected, but did it put the wire in the node wire table instead? And the node wire table is not remotely large enough for this, so it's probably written that somewhere else in memory. Yeah, that's not good. Yeah, that's interesting. Yeah, it's really interesting how special all the sprites are. Oh, we've like run off the end of memory here. Anyway, I think I had a slightly nicer example of this. Yeah, here's a weird gate from earlier. This is a buffer. I think this is a one input OR gate, which is being drawn with only single input sprite, and then the body is like an AND gate output. So I was thinking about how you would like have completely custom gates, because then I was wondering, well, what if you wanted a gate that acted as an interface to a MIDI device, and the gate could be labeled with a MIDI note. How would you actually do that? I think I would need to render the gate myself, because I don't think there's enough sprites in the game to do that, or even enough free sprites. I'd have to understand the special electrical meanings of the sprites a little bit better to do that. But if I had my own kind of sprite rendering hook, I could set it to sort of a higher sprite ID that would then get passed off to some JavaScript code that could render something higher resolution, maybe. So, yeah, so you can do weird things like that. And then, well, I was wondering, well, okay, so I could make new kinds of gates. Like, if you look at that data structure, it's really tight as far as allocation of wires and like nodes and stuff like that. But there's some interesting gaps in this where there's some extensibility. Like, in these gates, this byte indicates what type of gate we're dealing with. And I mean, while, you know, there are a lot of places where there's a byte that's actually just being used as Boolean, here they're already using it to indicate what type the gate is, so it seems like maybe less of a stretch. And we're only really using a few values. You could, for example, have a 2-input, 1-output JavaScript function gate that calls a JavaScript function. I don't know. You could extend this arbitrarily, basically. And to some extent keep this in the original save file or compatible with that format at least. Obviously, opportunities for extensibility in the chips. The chips have like a different kind of packed bytecode format, and with those you could do all sorts of things that involve like passing maybe even the entire kilobyte long buffer of chip data off to some other function that can do stuff with it. So yeah, lots of options there, which could be fun. I was also curious about just what makes something solderable, like what makes something an input or an output, something that you can attach a wire to. And I'm pretty sure that it is entirely just the sprite that it is. So, for example, let's see if we can solder to some shapes over here. Don't try this at home, kids. Make a solderable hexagon. Let's see what this actually is. Let's paste in our chunky visual debugger. This is object FA. So 1 FA is, if that was in hex, we'd be able to tell that's 38. That's interesting. I don't think the game checks like every object in the game to see whether it's a crystal and whether it should be flashing, but in this particular range of objects, I think it does do that. Okay, those are all high objects. Let's go back to low objects. Because all the electrical stuff is pretty low. So these, I think, are non-directional, so they're used on the prototype pins. I would expect that to trigger weird, potentially crashy cases, so let's avoid those. Here's something that looks like an AND gate and has an output on it, and appears to be red. That's really all there is to it. Oh, this is all messy. What happens when I recycle this gate? It probably just got recycled normally. Oh, here's another weird gate. This one's a 2-input NOT gate. Only the left input works, though. Okay, and this is not a gate. This is just a sprite. If I drop it in here, will it get recycled? No. Because it's not even in the right portion of object space. This is over in FA, whereas these are all down in like 6s, 7s, 8s. Well, the soldering iron lights up. Can I make a node attached to that? Yeah, and the electricity flows even. And if I change the color, I think I can make the electricity change. Is this the color? Yes. Yes, so I can turn off my... So, like, already I've created an object which could just be an electrical output that I interface with some Robot Odyssey logic. All I needed was an empty sprite, well, an empty or otherwise repurposable object slot, a sprite which is interpreted as an output. So I guess we'll need a bigger table of what sprites have what electrical meanings associated with them. And then to set the color to the proper electrical signal. That's it. And I think we can do something similar with inputs here. Let's keep incrementing the sprite. Let's cut this electrical wire actually before I go increment the sprite like crazy. Excuse me. Here's some inputs. So there we go. So I've just run a wire. I think there was some leftover state over here on that wasn't set properly. So that first solder didn't take, but the second solder worked. Let's see if I can do that again. Yeah. So, and that propagates and sets the color of this object. So, yeah, it's nice. Nice and straightforward. And then just using the sprite system, I can, like I was saying, there are ways of attaching sprites to each other. So I tried making something simple which has an electrical inlet attached to a square, as you might have guessed from my comment if you read that tiny text here. Let's reload this to get rid of my annotations. But yeah, so it's a regular Robot Odyssey save game. Nothing strange about this. But I've got this object here, which I can move around and use in my circuit. Is that really full speed? Oh, this is a little slower than a typical ring oscillator because I've got 2 gates in there. But yeah, so I've got a little oscillator and then sending the output to a square with an input. It's like a concrete block with a banana jack on the front or something. So, you know, you can imagine like embedding this in your world or something. And every single object, you can make it grabbable or not grabbable separately. So, for example, like right now I have it set to the square is grabbable, but the input itself isn't, which is typically how these work. So like here, the inputs on the AND gate are not grabbable, but the AND gate is. But I can actually set that flag if I remember which objects these are. So yeah, these objects are FA and F8. grab flag, so it would be 9FA and 9F8. Yeah, oh. So I think if I set 9F8 to 255, then neither of these are grabbable. So you could use that to make objects that you can solder to, but you can't pick them up. You can solder to this, you can activate it with the hot cursor, but you can't just like take it with you. Make that grabbable. Let's make both pieces grabbable. So now I can pick up the block. I can also pick it up directly by the little output piece, which is kind of fun. I don't know where the bounding boxes come from. It's interesting. I can take it with me, put it in a different room, wire it up to a big chip. Oh, I even took it into the big chip. There's a lot of logic in this game that tries to prevent you from bringing objects into the big chip that can't be compiled into small chips. And it looks like this is fine. So you can bring hexagons or whatever it thinks this is into the big chip. What happens if I try compiling this? Brace for crash. Well, who knows what it did? It probably just didn't connect it to anything. Huh. Well, that might be something to play with at some point in the future, but I think that's the end of this demo. Anyway, so we were just adding stuff to the game. Anyway, I mentioned trying to connect it to real-world objects, and so I was thinking, well, how about let's just connect the gates to MIDI. I might eventually want something where you can map an individual gate to an individual MIDI note, but right now let's just do that programmatically and just map all the gates to some set of MIDI notes. So to do this, I was going to use Ableton to do some software synthesis, and I'm going to set up a MIDI loopback device. So audio MIDI setup, MIDI Studio, IAC driver. I think we can just use this existing bus here. I just have to turn it on. This is like the built-in loopback for MIDI and OS X. Alright, and then I've got Ableton set up with just some droney thing going on. Oh, this is like a format synthesizer. That'll be fun. Okay, so then this did I actually connect this to MIDI? Yeah, IAC driver. So this should already be listening, basically. And then here, this is a little JavaScript one-liner I came up with. This will just give you a MIDI send function, which is initially no-op, but then as soon as you allow MIDI access, then that becomes a real MIDI send. So I've got that, I've got a reference to the game world. I'm storing the previous state of all the gates so that I can just look at state changes and emit note on or note off events rather than emitting events on every game tick. And then I'm using the same cheesy rendering hook down here so that every time we render a frame, which is not quite the same as every game tick, but is in this case going to be pretty much the same, we update all the gates. I'm just calling this for all 35 gates. This calculates the object ID for the gate, starting at the first gate and then 3 sprites per gate. And then we look to see if the gate's active by looking to see if the color of its body sprite is the logic hot color. And then if this state is changed, then we send a MIDI note on or note off event. This maps the gate to a MIDI note. Right now, this is just mapping them sequentially to half steps, which might be good for a drum kit. It would not be good if you were trying to do something tonal. So let's just change these to fifths or something. I mean, this is something you'd easily just like mess with until you find something interesting. And then this is the velocity, which is maxed out at 127. Yeah, so let's see what this does. Let's get rid of this other patch too. Let's get a fresh lab. Let's get an actually fresh lab. Okay. Ooh, that's unpleasant. Sorry. Yeah, just what I wanted, a bunch of note-ons and an exception. Expect a status byte. Oh, did I exceed the range here? Yeah, I didn't even think to keep them in range because I figured it was just an experiment. If it overflows, I don't care. But if it overflows, it gives me an exception. So 35 gates. Yeah. Now well, no, that does overflow. It goes up to 127 in MIDI, right? Yeah, let's just go by 3 instead of by 5 for now. We can figure out what we actually want this to do. Alright, so let's just... I don't know what state that ended up in. I think I just want to recompile this update gate function with a new version. And then restart the game's main loop. Or resume the main loop. Still getting an unexpected status byte. I tested this just a minute ago. Okay, let's try this without any multiplication. Okay, that's working. I think I was just getting out of range too easily there. Really? Are we actually getting note-ons, or is that just stuck on? Yeah, that's what I was looking for. So we can play with the voices and whatever. Pads might be fun. It's the dramatic OR gate. Anyway, so yeah, you can get different effects with like thinking about this as more like melody or percussion. I don't have a lot of live plugins installed on this machine. Where do these actually map if I send them to a drum kit? I might want to speed up the game a little bit just so that it's less sluggish to move things around. So this seems most useful to do with OR gates, but I don't know. XOR gates are pretty nice, actually. And NOT gates would kind of start off with their note on, sort of. So you'd sort of end up with the note on when the input goes off. This, of course, makes me really want a better hex editor, music sequencer, logic analyzer, just like all of that I could just like drop in on the browser side, or at least good interoperability with that. Like, I mean, I could write a file that I could load in something like GTK Wave, could write a VCD file and have a logic analyzer. But it would actually be kind of awesome to have a logic analyzer just pop up in the game, like in a nearby canvas or something. So yeah, then the question is like, well, what if you were going to try to make like a percussion sequencer with this? What would that look like? Would you use the robots? I mean, you could use a combination of circuits and having the robots kind of run through mazes and that kind of thing. Let's, because I don't want to run out of time before I get through all the demos that I wanted to do. Let me just load a circuit and see how this sounds. Oh yeah, I had that circuit I was prototyping for playing the adventure part of the game, that kind of cycler robot communication chip. Oh man, these serial chips might be interesting. Serial 4-bit adder. I'm only getting gate state though, so stuff inside. Oh. Huh. Right. So that's what delay lines sound like. Adder test bench. This isn't going to have a lot of gates in it though. I've got to oralize that signal that we're seeing though. Like this is the actual serial data. Let's find a gate that sounds good. Oops. You can hear the serial data now. Yeah, that's fun. Yeah, cycler transmit and receive. Okay, let's find some different samples for this. That's exactly what this should sound like, right? Sorry. I like this one. Yeah, okay, this is fun. We might have to come back to something like this. Oh, is this one fun? Remote controlled robot. Oh, this is great.
Okay.
Oh, why is this stuck? I need a button that just sends a bunch of node off messages. That's like way off the end of what's mapped. So this is a linear feedback shift register. It's basically a very simple random number generator. Okay. A bunch of that is just the sound of the evolving noise that's going on here. Let's have a simpler noise. Maybe something sampled. That's not simple. Oh, I was not expecting this computer to have like 0 of my Ableton add-ons installed, but I guess I should expect that. There's very little tone in there. Are those, is that like destructively interfering when there are multiple voices? Do I want an arpeggiator here? Good. Maybe just note length. Okay, what is this like without the feedback? What if I increase the ticks? So you can actually get much finer resolution and speed control than just those buttons there if you use the JavaScript console. Let's try 4x. It's still way too fast. Maybe 2x was pretty close to what I wanted. 1.5x? Another feedback path through a few other notes. Oh, right, it would help if I soldered the correct pins. Tim says it seems like I've discovered the indecisive OR gate, right? Yeah, I posted a couple of clips. Well, I guess I only posted one or two, but yeah, I was taking some videos of some of these experiments from earlier, thinking of calling it something like music for XOR gates. Yeah, let's get a, I don't know, this patch is interesting, but let's clear the lab and try something from scratch. We don't need to build this inside a robot or a chip or anything. We can just make like a music room. Let's make a music basement in the lab. It's like way in the bottom. Let's put up some sturdy walls. Okay, we don't need to eat up all of our usable space with walls. We don't need actual sound insulation here. Let's see. So this is with a couple layers of transformation. I've got my my JavaScript is now outputting pretty arbitrary MIDI, just OX24 plus the gate number, and then I'm transposing it and putting a scale on it in Ableton, which seems a little nicer than writing JavaScript to do that. These are mapping to the same note though. Let's turn off that scale. We could even try going back to percussion. There's so many gates here. Like, that's why I thought it'd be fun to do this using gates as the primitive, because, like, this is using almost half the sprite memory in the game, just the gates. Like 105 object slots for just the gates, not the flip-flops, not the nodes, but just the proper 2 and 3 terminal gates. Oh gosh, I don't know if I have enough patience to arrange like an actual melody right now. But it is tempting. I'm gonna have to end the stream in like 20 minutes or so, probably. Actually, I should go sooner than that. I always cut my schedule too close when I shouldn't. Let's see what this is like with percussion. Let's go back to one of these basic drum kits and take all this stuff off. Oh, these are like way... Where's my transpose when I need it? Alright, it's pitch. Oh, I already had the pitch in there. It was just off the left. That's why it was so far off. Okay. That's better. No transpose necessary. Okay, let's not sort these too much. Let's just start connecting them. I'm like, why doesn't it connect? Yeah, doofus, you've got to connect the inputs to the outputs. What about a counter chip kind of pulsing through these different branches? Let's go get a counter chip from upstairs. I don't know if I want to make the clock signal with gates, because that will cause the gates to make noise, so let's get a clock chip and a counter chip. Binary counter might actually be great for this. Yeah, let's use binary, because that actually fits music really nicely. Excuse me. Let's use this as a suitcase. This will definitely have to be the last demo, but hopefully I can make it good. So you're a clock chip. And you're a counter. I don't know what clock speed to use. Let's just use that one. And let's reset as soon as we get to the end. Or maybe just before the end. This is basically our time signature. We might have to adjust this. That's not actually good at all, but... It's getting better. And of course, you could record this if you wanted to. Getting the zoom key in this app. I'm usually running Ableton on Windows. Maybe I just can't do that while I'm recording. No? Well, that works. I don't know why I fail at UI. I fail at UI a lot. Oh well. Yeah, so you can make weird rhythms. It'd be interesting to maybe combine this with some pseudo-randomness with kind of more of that LFSR style. For example, what if I put this back in the chain? Like, these sounds are kind of too jarring for that particular combination, maybe. Yeah. All right. Well, I should pack up this stream and head on to do other things soon. But I feel like I at least wanted to show folks what was possible with a little bit of hacking around. I should really put up these notes somewhere because I've got some things in here people might want to play with. It's extremely messy though. Yeah, maybe I'll just throw this in the repository with the source code. I don't know. I'm just going to call this funthingstodo.txt. Okay, so if you want to actually play with these, I just committed this to Git. If you go to the source code, you don't need to compile this. You can go to robotodyssey.online and just use the JavaScript console. And you can just paste in stuff. So there's this visual debugging DOM style. And that's what will give you the ugly overlay things that help. Uh-oh. Oh, right, because I had already patched render frame. Okay, so if you patch render frame twice, maybe don't do that and cause infinite loops. But yeah, this is that patch, which works on its own. you'll have to modify this if you want to patch multiple things into the render loop currently, because this is a huge mess. And here's that MIDI experiment, just as we were using it. So yeah, I hope you enjoyed that, making some beats, such as they are, with an electrical circuit made in a 30-year-old simulator for kids. So yeah, I'll see you folks next time, maybe with some electronics in the real world soon. See you later.